focused, but we also do full stack, so I've done stuff in Scala, Node, a lot of Ruby on Rails. And we also created our own product called Polanco. So we use our consulting company as a way of bootstrapping our own products. And so this is our current product that is built completely on Ruby on Rails, and we're currently migrating everything over to React. So I started working with React like really in depth full time about a year and a half ago. Started exploring a little before that. And when I was consulting for a very large company, and they were actually doing a multi-divisional process of wanting to move over and across all their divisions to a technology stack. And I got brought in to actually determine what that stack was, and that's where I was comparing Knockout, Angular, Backbone, and React. And React became the winner. And through that, we actually started building a multi-divisional product that is actually built as a kind of a UI framework on top of React that we actually deploy across all this. And so that experience of building a framework that we use to build other technologies was an interesting process. You have to start digging into the internals of that framework. And that's what's actually led me kind of deep diving into why the lifecycle is important, and that's what kind of led to what this presentation is about. So here's a quick breakdown. What we're going to do is I'm going to talk about what the lifecycle is, why we need it, why is this important at all, and then we'll actually deep dive into each part of that and tear it apart and look at what we can do for also, just building better applications, but tying in third-party UI integrations, tying in third-party events, and also optimization possibilities. So overall, I'm going to start relatively simplistic and kind of get deep. So for those who don't have a lot of experience in React, I hope you can keep along for most of it. For those who have been dabbling a little bit, I think a lot of this will make sense. We're not going to get too much into code in this kind of this presentation, but we're going to kind of walk through what this is and how we can take advantage of that. All right, so first off, the lifecycle, we're going to go like, what is the lifecycle? Why do we even have it? So a lifecycle is very similar to like what we with an organism. We start with the idea of birth, we go into growth, we spend most of our time in that kind of growth phase, and then eventually death occurs, right? So following that pattern, React has created this for us. So there's the idea of mounting. I'm actually getting the component and the application ready to mount onto the UI, either native or browser. I then interact with it. I add data, data changes, we talk to services, that's the growth, that's the update. We spend time in that update phases, right? The user tracks, swipes, does things with the component. And then eventually we no longer need that component. We no longer need to have it, so we unmount it, and that's the death of that component. Now what's interesting about the lifecycle is that this actually occurs for everything from the application all the way to the most minute component. So every component of our application goes through the lifecycle, just like our application goes through the lifecycle. So keep that in mind. I'll reiterate on that as we walk through, but this is something we actually we deal with over and over and over again down the stack. So how React handles this is that they actually provided a series of hooks for us, and a specific order of operation that we can tap into and take advantage of. And this allows us to know more about what we can and cannot do at that point. So in the mounting phase, this is what we're talking about, the creation, the instantiation. We're creating a class and actually turning it into an element, getting it ready for actual use. We're initializing props. We're configuring it. We're getting it all ready for first render. We're talking, bootstrapping and scaffolding third-party UI elements when we need it. And then we now mount on the UI. Now in the growth, like I said, that's changing of props, changing of state. This is what actually triggers another update phase. The user might interact with the component. They might click on a button. They might swipe something. That triggers the update of that component. And then your third-party libraries are tying in, so they might have their own events that actually trigger and kick out something like the date range picker, which is a really powerful bootstrap date picker that has its own event architecture that you can tap into and then actually bootstrap that into your wrap component. And then eventually, we don't need it anymore, right? So we need to properly clean this up. We need to unmount it from the native UI. We need to clean up our app ourselves so we can actually prepare for garbage collection and don't have memory leaks. So this leads in. So fundamentally, why do we have a lifecycle, right? So all frameworks have life cycles. Who here used Flex? 1, 2, okay, cool. So I got into Flex. For those who don't know what Flex was, it was a Flash-based UI architecture developed by originally Macromedia and Adobe. And that's where I first learned about a lifecycle. In fact, that's where I actually spent a lot of my time, was actually going around talking and write a 60-page white paper on the lifecycle. And it's kind of ironic, 6 years later, I'm once again speaking about lifecycles. I just can't walk away from them. But what it really really is, it's a methodology, that's all it is. A lifecycle is an approach to doing UI component development. It's a way of knowing when data is available to me, it's knowing when I can interact with the data, it's knowing when I can actually trigger things, and have it predefined. By having a lifecycle doesn't mean I'm going to have a better framework. That actually does not define a good or a bad framework. It's just a methodology we take advantage of. React and the developers of Facebook felt this was a good methodology, so we can take advantage of it. So, like I was saying, it's really just a series of hooks, right? So there's a series of methods that we can actually tap into that gives us the capability to know where we are in that application, right? Where are we in that component's lifecycle? What are we doing with that? Allows us to actually do configuration, pre-configuration, updates, and very specifically, they come in a very particular order. And that's really important, because order matters here. Because now we know if this method is being called, we know that's because they've done an update. We're in the update phase. If another method is called, we know we're actually getting ready to unmount. So it gives us a really clear pattern as developers to understand where we are within that component, within the component's children, within the application's cycle at that point. And so the key thing here is I want to call out at the very bottom of the word of caution. The challenge with this is that if we make the wrong decision at the wrong time, it can have pretty nasty repercussions. We can get into infinite loops. So if I make the wrong decision, call the wrong method at the wrong place, we can actually just start getting stuck. Now, React's generally pretty good about warning you, especially in development mode. It'll catch that going, you did something really stupid, so don't do that, please stop. But sometimes it's not obvious. And these can be some of the trickier things to debug when you're doing as a developer, or all of a sudden, like, why did I just run out of memory stack, right? Like, those are some of the worst things to debug. You don't know where you were, and you don't know what spawned it out. So keep that in mind as we start delving into this, that we really want to make sure we're using them in the right way, because if you don't, you can find yourself in some pretty unfortunate situations. I've been there, and I've learned that the hard way. All right, so let's start off with Earth. So here's the order of operation and what's available. Now you'll see that I have order markers here. One of the challenges that we're having now is we're seeing, and it's a beautiful thing, but it's also a challenge, we're seeing a radical shift in how JavaScript is being developed, right? We're seeing ES6, we're changing methodologies. So the React team started with the idea of what's called the create class. So it was pretty much a factory pattern. I feed it an object, here's your information, create me a component, awesome, generates it. But now with ES6, we have actual classes, so they have to also support that. So in both ways, we're going to look and support both options. We're going to talk about the classic create class. I'll call it out. We'll talk about the ES6 way, because they're very similar, but there's some slight modifications we need to keep in mind. So we start with initialization construction, and then we start with the default props. So the concept of default props is like, my component's going to get past a series of props. I might not have everything I need yet, so here's a way of actually defining default props. We do it as either if you're doing create class, it's a method you define on the object that's passed to the factory, or you define default props on the class as a constant. We have get initial state, which configures our initial state, that's often it says, or you set this.state in the constructor. Then we go into component will mount, we go into render, then all the children go through this, and then we come in and finish up with component to mount. So this is what we consider the bird. They happen in this order, happens very in linear, synchronous order, and we can take advantage of that. So let's kind of break each of these down, right? So initialization, the idea here is when I go and create a class or I create an extended React component, it's that process where I'm actually starting to create an element from that component, right? This is where I started the initialization process. So kind of the pseudocode below, I create a component, it's my component that I'm creating, and create an element, passing in props and children, and then actually mount that on the DOM with that first render. And that kicks this whole process off. At this point, we're now starting initialization. We're actually going to start working through that workflow. And so keep that in mind as we walk through. So now the first thing it has to do is get default props. So the idea of props, if you go back to that code, we'll see that we pass in a series of props. That prop's just an object. That object is the configuration we're passing for our component. The problem with that is we might have properties that are optional, right? It might be a color, it might be a click event, right? But there's things that we actually want to default to. So when I have a component in that button, if they don't define a text color, I want to actually have that as like, I want that by default red, and then you can override it. So what default prop does is says, okay, I want you to take the props that are passed to me. I'm going to generate a new object out of default props, and I'm going to merge them together. And I'm going to use that as the props that actually start off this process. So if you guys use Lodash, it's kind of like .default. The idea is we have a base object that gets passed in and looks at it and says, do I have all my properties they match? No. Okay, great. The default props attach them on. So what that allows us to do is it allows us to kind of have these defaults. There's a couple little tricks we need to keep in mind. Let's say I have an object, a property called foo, and I set foo : undefined. That's how my prop's getting passed in. The way defaults works, that process of merging is we go, okay, that's undefined, I'll take my default and set it on. Great, awesome, I can take advantage of it. But if you set it to null, you've essentially set it. So this is one of those tricks of JavaScript. At this point, you can see the code, foo : null, that is now a set prop. So if you have the default, it won't see that, it won't set it. So that's one of those things you need to be careful about when you're defining your props for your components and passing them down. You want to make sure that you're not setting null, or if you do, your component handles it. Because otherwise you'll have all kinds of funny issues where all of a sudden you're trying to access properties of null and you kind of wonder why. So that's what default props is all about. The next step is get initial state. So similar to props, state is also an object, and state is the internal mechanism that we can manage that kind of represents the state of the component. Very similarly, it's a method that returns this object, and it defines it as what our default should be when this component boots. By default, in React, if you don't define the initial state or initial state, it's null. Keep that in mind, because if you take advantage of state, let's say you have a div or a UI element that needs this.state.active, and you don't set a default, what is happening is state is defaulted to null, and so that means I'm trying to go this.null.active, that will cause a problem. So this is why we need that initial state. So it's one of those things, if you use state in your component, I highly recommend defaulting and using the initial state, so at least you always have an object on this.state. Something to keep in mind. I want to kind of like do a little side note here about state. State is an interesting beast in the React community. 3 to even 6 weeks ago, it was kind of like, don't touch it, don't use it, everything's non-state. Now we're starting to see, like Dan Amarov just wrote an article a couple days ago talking about, oh no, we use state all the time on Facebook. But he was like the guy who built Redux, who was all about state is the devil, don't use it. So we're seeing like a continuous change. So I'm not going to get into that debate, is state bad, is state good? That's for someone else to talk about, but the reason I mention this is because I'm going to be talking about state a lot, because that's a lot of what we do in the lifecycle is managing state. So I just want to kind of throw that out there. I think it's ambiguous. It's like state's not good nor bad, but it's something that's definitely tricky with React. It's like, when should I use it, when should I not? All right, so we have our props, we have our state. Now what'll happen? So at this point, we get our first kind of hook method. This component will mount that says that it's shared both by ES6 and by the Brave class. And this is kind of our pre-render. It's a capability to do some work before we actually go and render the screen. So at this point, I can call this.props, I can call this.state. They are configured because this.props is a merging of what props are passed in and my default props. This.state is the initial state that was defined. I can go in and call set state at this point if I want to. It is safe to do this. So this is kind of a way to look at the data that came in, look at my props. Maybe I need to generate props based upon that. Maybe I need to do some other configuration. So fundamentally, what this is really about is pre-configuration. So for example, I can do calculations based on those 2 different props. I can look at that and actually create a new state based upon that. If you're following the managed component process, we might come in with a default value, and I can take that default value and convert it into state and start managing it internally. If I'm using a Flux-like pattern, I might register the store events at this point. I can start registering a window and a native UI events at this point. So maybe I need to handle resize. This would be the method I come in and actually tap into. So at this point, this is the way to actually start mounting in here. Now, it's key to note that the DOM, if you're working in the browser, or the native UI does not exist yet. You have not been mounted to the UI, so you can't query and ask for things about that yet. We have not actually rendered, so keep that in the back of your mind. So we now are about to mount, so we actually mount. So anyone spent any time with React, you know that you spend a lot of time with render. This is kind of the method we live in. So this is our first render. This is when we're mounting. The render is generating our UI representation that will then be passed on to the native layer, which actually gets put on the screen. So at this point, it kicks off that process, but more importantly, it also kicks off any of your children. So let's say I have a data grid, and my data grid is made up of rows. Each of those rows are components. And each of those rows are made up of cells. Those cells are components. And those cells then have other components. We have this chain, a hierarchy going down. So if I'm at the data grid level and I'm starting the mounting process, I need to make sure that all my rows are initialized, all my cells are initialized, and that's how this process happens. So we take that render off, and the component will mount triggers the life cycle of those children. At this point, this dot props and this dot state are baked in, but we can't call things like set state. We can't call force update. We can't call the DOM at this point. Anything that would manipulate and cause a re-render or change the DOM or native UI, they don't allow a render, which makes sense, right? Because if I'm in render and I'm drawing the screen and then say, hey, wait, I want you to re-render, now we're just in infinite loop. So render is all about taking what I currently have, putting it into the native UI. Now we're mounted, and now we go to the children. So just like I was saying, here's like a kind of representational tree, right? So each of these components will go through it. So we start at A in the top one, that goes into A0. A0 will start its initialization, construction, default, component will mount, render, which then goes into its first child and then walks its way all the way down the train as deep as that goes, right? So every single component goes through this process. Now, once they go back, they actually walk backwards from the bottom up, calling component did mount. We're now rendered, we're now mounted, we're now on the UI. Now we can actually tap into the component did mount and start actually, now I can actually start doing ref access. I can start actually interacting with the DOM. In fact, at this point, I can call set state again. I can call force update if I so desired. I can't really think of the use for that, but you can. Now, what's interesting about component did mount and component will mount is they're only called once, right? We're still in birth. Birth only happens once. These methods are only called once. So we don't have to do things like check flags to see, like, am I going to get an infinite loop if I call set state or force an update and render here? Because this method only gets called once. So it's, quote unquote, relatively safe. You have to think about performance issues, right? If I'm costing a re-render, but why would I want to do that? The reason you might want to do that is now that I'm on the actual native UI, now I can actually determine what size I am. I know what my children are sized. I can actually start looking and inspecting that, and that might drive how my application behaves. So I need to actually query and pull that data back, and then maybe set state and start a re-render, right? This is when I would actually, if I want to bring in like a jQuery UI plugin, this is where I would actually mount it. Now that I actually have access to my DOM, I can actually start mounting that and feeding all my data. So we come in and actually have that capability. So really, this is like the place where us tie in and now know, like, hey, the state of the world. I can look around at my UI, I can see how everything's configured, and I can make decisions at that point relatively safely. I know this is occurring. So, for example, the very bottom, that was kind of a little hard to read, some pseudocode. In this case, I'm actually going and getting the DOM for my picker, which is div, and I'm mounting the date range picker, which is jQuery or Bootstrap component, and mounting it. And this would be done inside of a component did mount. So kind of recapping birth, right? So here we are. We start with our initialization construction. We get our default props. We get our initial state. Component will mount. We render. We're now mounted. All the children go through the same process. And then we back our way out and finally do component did mount. Now, one little comment I want to throw out here is that technically default props happens in ES64 initialization construction. This is actually set as a constant on the class. But I mean, really, I just want to call that out. Okay, so that's birth. Now growth. This is where we spend all our time. This is like 99% of the component has been spent in this process. And once again, we have a very particular order. We have component will receive props, which is followed by should component update, which is followed by component will update, then render, then all your children go through the exact same process, and then component did update. Now there's certain things will happen here that we'll talk and like some of these times this cycle will break. I'll explain why and when we do that. But fundamentally, this is what we just go through. We go through this process over and over and over again. So component will receive props. This, to me, was one of the more confusing things to kind of get my head around is that props this method can get triggered for an inordinate amount of reasons. We would assume component will receive props means, hey, I'm getting new props. No. What that means is my parent above me has changed or something's happening, and I'm feeding your data again. That data might be the exact same data. So we look at like a redux system where it's all we have this large state machine. The top component might get a new render, which might have one little section of the data got passed, and that one component references it, that data is passed. But the rest of the application, none of its data has changed. You still might get past that data. That data might come down the chain, so we hand that data down. So when we actually start interacting with it, this method takes one argument, it's called next props. We need to make sure we need to check, did props actually change, right? Because props might not have changed. So we have to make that first assumption, right? Like we can't just assume, hey, this method been called, my props have changed, awesome. So you got to do that consideration. So what this allows us to do is this gives us a chance to say, hey, I got new props, the next props, I got my old props. Do I need to do anything about it, right? And so what this allows us to do is allows us to do things like, oh, cool, I do have new props. That prop now affects my state, so I need to reset my state. I can call this .state. So this is really the place that we can set our state safely based upon the props that come in. And it's kind of a pre-flight check for should component update. It allows us to get everything kind of our ducks in order in a row before we actually start and determine, do I need to actually render? Did something actually occur? So that leads us into should component update. This is really where a lot of the optimization occurs. I think one of the misconceptions with React is that, oh, it has a virtual DOM. Awesome, right? Like you can do all this, you can do dipping, you can do flying force, that's great. Yeah, that gets us a lot of the way there, but this is the method that really gets us deep into performance. Because what this does is it allows us to say, hey, did my data really change? Did my state really change? Do I actually need to render? If I return false from this method, we stop and we exit. And that means I exit for all my children. So you can see, like, if I have on my data grid and I get new props, and then should component update comes in, and I look and I say, none of my data changed, none of my state changed. Why would I want to re-render all my rows? Why would I want to re-render all my cells? Why would I re-render all that? So we can, at that point, say, nope, we're done, hit false and fail, and we can see massive performance increases. And this is like, I have from first-hand experience, we were building a heavily, a data list, where we were doing some really heavy optimization, and this is what saved us. Because I was just starting to use React, I'm probably like 3 weeks into it. And I was like, man, this thing's supposed to be so fast, but as soon as I need this thing 1,000 pieces of data, the whole thing dies. Why? Oh, because I wasn't doing this. So, because by default, should component update always returns true. Like, always assumes, like, yep, it's time for you to render. So, we have to actually take advantage of this method and actually start tying into it. So, what's cool about this is there's actually a couple of libraries out there that can kind of help us get us halfway there. The first one is Pure Render Mixin. That's actually made by Facebook. Probably a lot of you have seen it. The other one is Immutable Render Mixin, which uses Immutable JS. I'll talk a little bit about how they work, because that kind of can let you conceptualize how you can take advantage of component update. So how Pure works. 2 examples, the Create class, they use the Mixin. Of course, Mixins are going away. And then we have ES6, which is actually how we do our extension. You can see all they do is we call the import, bring our reference in, and then we define our should component update as a method. And so what ends up happening is we mix this in that way. Essentially, we said, hey, whenever my component gets called, whatever should component update uses Pure Render Mixin. So what does Pure Render Mixin do? It does a shallow compare of the current props and the next props, and the current state and the next state. And what I mean by shallow compare is, remember, those are objects. So I look at the props objects, I look at the next props objects, and I compare them property by property and just do a triple equals on each of those. Works great if it's true. Works great if it's a string. Doesn't work so great if it's an object or array. And that's why they call it pure. Because the problem with objects and arrays is they're immutable in JavaScript by default. So what that means is I have an array called foo. Foo has 3 items. Right? That's in my prop. Foo, array. Somewhere else, I call foo.push, push new data on it. When I call triple equals on that array, it's going to return the same. Yeah, the next props and the old props, they're the same because it's actually looking at the reference of that array. It says, yep, that's the object reference, that is the right reference. It doesn't know that it actually has changed internally because it is a mutable data structure. So therefore, Pure is going to say, yep, no data has changed. So we would never know that data changed, we would never get that re-rendered. So that's why when a lot of people talk about immutability in React, that's why they actually really encourage immutable. So immutable render mixin, very similar process. You either do a mixin or you actually have a decorator pattern, but fundamentally it's the same thing. You wrap the food component in it. And what's interesting about immutable, who here has actually worked with Immutable.js? Okay. Who's completely unfamiliar with that idea? Cool. All right, awesome. So what Immutable.js does is the guys at Facebook have figured out how to create data structures that you cannot mutate. What that means is when I interact with a list, and I say .push, that if I have that, like my variable name is foo, I call foo.push, foo never changes. What push does, it returns a new object. And now I have bar. Bar is now the representation of that. And what that means is that because I can never change that structure, I can start doing comparisons. I can say, hey, is foo equal to bar? No. But actually the data has changed because I actually have to generate a new object every time. And what's really fascinating about what we have done is we can actually compare incredibly deep trees and do really fast tree management, and they actually generate a hash code that's a unique identifier of that data structure. So I can take an object called converted to immutable. It can be ND of object array, object array, object array, and it builds it up, and actually immutable will actually map that and say, okay, this has a hash code of 01355F13. That's the representation of that. So I can take another object and shove that into immutable, and then compare them, and it's really quick. It just compares hash code. And it knows that, yes, the data representation is exactly the same. So what that allows us to do is now, instead of having to worry about, did someone mutate my array, I can just triple equals it, more or less. That's an immutable is does that for us. It actually looks and says, are you the same object reference? Do you have the same hash codes? No, you're different. Oh, yes, you are. So now it overrides our strict component update and allows us to actually really quickly, did my data change? Yes or no? Cool, awesome. It doesn't matter how complex my data is. So that's one of the powers of immutable. But it is a tricky subject. Immutability and actually integrating that into your application, kind of getting your head around that, especially with tree traversal, is kind of a pain. I've done a lot of it, and I've had a love-hate relationship with it. But it does give us the capability of getting really powerful rendering because of that. Okay, that's your component update. A little sidetrack about libraries. So we have component will update. So you'll see this pattern. We have will and did, right? So now we have will update. We're about to go to render. Now, the interesting thing about component will update is that for the longest time in my mind, I saw this as component will mount and component will update as very similar methods. They seem similar, they feel similar. You do not call set state here. That's the interesting thing. Component will receive props, what we call set state. We do not and should not call set state component will update. So it kind of made me think, like, well, why do I need this method, right? That was the way I looked at it. Cool, like I'm about to render, I have all my props, my state, I do my populations. If I need to actually set state, I can do that, and then we'll go to render. Nope. If you call set state here, it immediately jumps back to the component will update. And if you call set state again, it'll just keep spinning out. It's a very tricky place. What it really is good about, though, it's about picking up animations. I know that I'm about to re-render. Maybe I know because of my props I'm moving positions. So I can start transition or animation, a fade in, a fade out, a slide. I might have internal variables that I manage on that class that aren't actually part of state. I can actually interact with that. I might need to dispatch events. Like, hey, look, I'm about to update. I need to let my parent know, or my parent's parent know, or let some other subsystem know that, hey, I'm about to actually update, let everyone know I'm about to do this. So it's not a commonly used method, but it does have uses. It does have some things that make it really important. Once again, we enter render. We all know this. Same thing applies. The same render method we saw in the birth. It has a capability. Now, what's nice about this, like I said, we have should component update returns false. We skip. We never hit this. There's no reason to render. We're done. We move on. So render only gets triggered if we actually need to update content. And then we go again to our children's life cycles, right? And this sort of things get really interesting because now we're starting to get actual components starting to get into different life cycles. So in my example here, the yellow or orange, depending on how the color prints out, is representative of data changes. Things have changed, right? Red is representing deleting. Blue is things that stay the same. Green is addition. So all of a sudden, our bottom component, A3, is a new component. It's just starting the birth cycle. The blues are skipped. They're going to come back with like, nope, my data didn't change, so I'm not going to do anything. The orange is like, oh, my data changed. What's trigger is me deleting something. So now all of a sudden, these components are all cycling and going through life cycle. Well, they might not be going through the same life cycle at the same time. But the idea is it cascades. So if at my top child A at the very top, I return false for should component update, none of my children will ever be triggered. So it just gets cuts it off right there, and we're done. So I just want to kind of reiterate. And then we go through the same thing. They'll receive props. They should want to update. They'll have their own should they couldn't update. And then they can short circuit and say, no, my children don't need to render, nor do I. And if they do, the component will update, we go to render. And if they have children, they go down the chain. So once we're done with all our children's life cycles, we spin back up the component to update. So this one really mirrors component did mount at this point. Our DOM is, or our data UI is fresh, it's ready, it's all laid out. We get previous props in the previous state. So in this method, if I call this dot props, that's the current props, and I can compare it and I can make decisions. This is a good place for actually interacting with DOM and native UI again, right? So I can actually go and access that. And if I need to call set state or force update, I can. But this is where things go really ugly and go south if you do that wrong, right? Because if I'm a component did update and call set state, which triggers component will update, I've just entered an infinite loop. So whenever if you're going to have to go do these things, I call it double render, you need to make sure you flag that pretty safely, because that might cause a problem if I don't actually track that correctly. It's going to loop infinitely. So why would I want to do that, right? Why would I ever want to call a set state again? Maybe my browser resized, right? And now I have to wait for that DOM information to tell me, oh, crap, I'm a different size now. Now I need to recalculate my position and my children's position. So maybe I do need to do a second render pass at that point. So there are use cases for that, but then I start thinking about optimization. Do I really want to render again right away? Do I want to get in that process? There are times and places for that. And that's why you don't want to actually call that. But if you did that, you want to make sure, like, did that value actually change? Am I already in that state? Do I really need to re-render? So you got to keep that in mind. Again, this is when we interact with our third-party components, right? Because now that our configuration is all done, we're now not going to feed it new data. I can start dispatching events. So again, it's like a very common pattern you see with these methods. You do the same thing here. So that's update, right? Component will receive props. Should component update. Component will update. Render. Children. Component did update, right? And so that leaves us with the final part of the lifecycle, death. And death is really easy. It's one method. Component will amount. And then children go through the same component mill, and then instances are destroyed at that point. This is all about cleanup. This is about our capabilities going in. Did I create and spawn new third-party UIs? I got to destroy them. Did I tie into events? I need to unregister. Because if I leave anything dangling during that destruction, this is where we get those memory leaks. Because I didn't take the time to clean up, they can never get garbage collected. They never come in, the system can never clean it up. So this is our place to come in and pretty much unwind everything we did when component did mount and component will mount. We can come in and clean up after ourselves and then get out of the system before it's done. And then, of course, the children, they do the exact same thing all the way down. And this is all the children will get this. If I'm pulling out the parent, that means all the children are coming with me. They all have to be destroyed. So they'll go through that exact same process. And at that point, our instance has been removed, the component is no longer active, and now we can be garbage collected by the system and company sweep us away when it's time. So death, really, really easy and simple. But it really, really important, because without it, we have some pretty nasty memory issues. So that's pretty much the life cycle in a really split, fast way. So if you guys want the deck, it's down at the bottom of my bit.ly. I've been working on a open source Git book where this is all written out in excruciating detail. It's about 40 pages with diagrams talking about and a lot of code examples. And also we have another one. The way we're doing the Git book is that we're doing it in a way that we assume, like, we're not trying to write a book for basic beginners. There's some great books out there, right, for that. There's a lot of great resources. We want to focus on more of the more advanced topics, like the life cycle. We have another a section that I just finished writing. It's all about component composition. How do we actually evolve and componentize components that we have? How do we actually think about that? And what are some examples of that? And then there's a pure render mixin. If you haven't read it, I highly recommend the second link there. The A implies B does not imply B implies A. I can barely say it, but it is a great article about why and how you will get burned by pure render mixin if you don't keep your things pure. lot better than I expected. And then on my Twitter, I'm James Polanco. So that's my presentation. So if you have questions, we have a mic over here, and I can definitely take time to talk to you guys. Thank you.
So we have a chance to do some questions. Is anybody, let's see, let's get this out. Who has questions? Back here.
So you talked about React and obviously React has the same lifecycle, but like React dynamics and all those other things. Is that about React as well?
So the question, if I heard you correctly, is does React Native and React UI or browser have the same life cycles? They apply correctly?
The lifecycle, so I know that they're about the same, but you talked about the dynamics, and was that also applied to React Native and immutable dynamics?
It should, because all Pure and Immutable is doing is actually doing the data compare, right? So that is actually still part of the React internals at that point, because it's really like, did my props change? Did my state change? That's all they're really comparing. So unless native is short-circuiting that somehow, which I don't believe it is, it should apply exactly the same.
Okay, and also, as far as like sizing of the elements, we talked a little bit about when you did launch, you already have sizes, but in my experience it didn't, and we have to look for on layouts, OPACs, and you know, put sizes on animation specific things. Can you talk about that also? Like, how do you actually get a size of that?
So how do I get sizing? Yeah, so that's a tricky one, right? I think how do we get sizing in the process? That's where we get into these kind of tricky, nasty second renders. Because there's two ways of approaching it, right? There's are you guys familiar with React Virtualizer? So, really awesome library. The process of virtualization is the idea that I have a viewport of X and Y pixels, right? 100 pixels by 500 pixels. That's my viewport. That's all the size of data. I have 10,000 items I need to render. Why would I want to render all 10,000 items? I can only show maybe 25 at a time. So the idea of virtualization is I will render 30 items, and then as the user interacts with that, swiping, I will like if they're scrolling, I'll take things off the top and reuse components and virtually create scrollers, virtually create the layout dynamically based upon what's actually currently viewed. So that library solves that problem by you having to explicitly define size, right? Because the problem is, exactly what you said, what size is that viewport, right? It's really, to do virtualization is really easy, quote, easy, if I know the X and Y. Because I can say, okay, cool, I can figure out, and I know the height of each row and each item. Once you get into dynamic row heights, once you get into dynamic sizing, all of a sudden that kind of goes out the window. I can't use basic math algorithms to calculate that. So one of the things we've ended up having to do is two passes, right? The first pass is layout, and then wait for the native or the browser to do its layout, and then on component did update or component did mount, go and start querying. How tall are you? How tall are you? How tall are you? Making assumptions like I know a minimum row height of 25, so I can say I know at least it's going to be this. So those are the kind of the challenges. But the problem with that is that, and then that drives state, right? So I'm actually managing that in state. That means I have to trigger a second update. Now the question is, do I have to re-render at that point? So there's ways we can short circuit that. So if I don't need to actually re-render, let's say I just need to know the sizes, I can use internal variables at that point. And I can, so that would be one of those places where I can say, hey, I know my current X and current Y is this. I'll tie new events whenever I resize all of this, update that. And only when my data changes or I know I need to re-render, then I can re-render at that point. But there will be those times that I have to kind of like peek under the covers and figure out like, oh crap, it changed. Let me go re-render and take that hit. But we try to avoid that. In fact, that project I was talking about, that was one thing that we had. They actually had an infinite Twitter feed, right? On Twitter feeds, yeah, I know the characters, but we had images and links and avatars and hover states and all these things you need to worry about, right? So how do we actually create a virtualizer and that does that? And it was one of those things where they kind of like, well, you know what, we're going to just like eat it and just say, here's our height for this for the moment, and then we'll circle back and look at double pass optimization. That's kind of the drives the.
Like A/B testing, like if you're going to run experiments on like crazy.
Okay, so cool. That drives the information to us and tells us that I did the A design, so to show the layout of A, but I did B design, show the layout of B. So it's like, okay. It's going to be really dependent upon. Okay, there's a couple different ways to do it, right? So the idea is every view A/B, or is it the application A/B, right? If it's every view, if I'm breaking down a sub-view, then it's the A/B driven. And that I might be seeing A in one and B in another and C in another in that same app experience. Then it's something that needs to be more at a component level that is driven. That can still be in that master state. It can still be using MobX or Redux or Adobe or Flux. You can still drive that at that point. And then like kind of query it up. So it depends on how, is it based on user interaction? If the user chooses a certain thing in a certain order, does that flip something? So at that point, it can be that business logic that triggers and says, okay, the user clicked on the third object, now they click the button, that triggers the system to talk to optimize it. It says, give me that state information. Okay, cool, I can bring that in, and now I can render that out and display that. That's kind of off the top of my head how I approach it. It really depends on how you're managing your data prop system within there, and then how granular your A/B testing is. It'd be nice if like my app is like they're in B mode, it's always B mode, it's flat, done, it's easy. But if it's all that granularity, and especially if it's based on user interaction, then you have to start having the business logic layer. And that's why I would actually still, I really like the Redux, Flux, whatever pattern you're using, and extrapolating and making relatively dumb components. Because what ends up happening, and I've been burned by this in the past, is that I like end deep into my stack, my UI, and that's what's changing, and all of a sudden my design team comes in, or our product team comes in and says, yeah, we need to move that over here. So I rip it all out, move it over here, and all of a sudden the whole thing changes, right? And if I'm all managing state, and the parent bucket's managing state, the parent bucket's managing state, now all that stack has to move. By isolating that information out, it makes some of these things a little easier, in the sense that I have business logic that's now isolated. It doesn't care about what the layout really looks like. It's like, okay, component F, or whatever your user display. User display, you're in mode 1. Okay, cool, now you're in mode 2. And then that is like broken out. So now as a developer and designer, I can move things around the screen a lot easier. And that's all the business logic, all the data is managed kind of behind the scenes. It's not really tied directly in. But it does add things like I have to make sure that everyone gets fed the data. Some passive props can get like, down the chain. So, but that's kind of the experience so far. Awesome. Good questions.
Yeah, so are there any things that make you like to use React versus the other frameworks libraries?
Sure. So that project I was talking about, they originally internally, I joined the team, I was acting as a consultant contractor for that company for about 5 years. And actually went through 3 buyouts. That was really interesting process. They kept me on as a contractor and consultant, but I watched go from a very small startup to a bigger startup to actually a real company and being bought by a very, very, very large company. And how that changed. So that was a long legacy of software. So what we were mainly using was Backbone and Rails. That was fundamentally what we were doing. And we were getting to the point where now, on top of that, it was spread out across 4 different Rails apps. And there's a lot of type layers because there wasn't really modularity thought at that point. So you have a spaghetti system that came in and said, how do we actually approach this? So I had to go in there and go, look, okay, I know my developers in this team understands Backbone. We go continue with Backbone and create a new system. That company had built an entire framework on top of Knockout. How hard is Knockout going to be in Learn? Okay, do I look at Angular? Well, we're still not at Angular 2. That was like, there's no way I was going to start a project in Angular 1, because we knew 2 was around the corner, still around the corner. So it was like, okay, that's not exactly what I want to do either. We looked at Ember, and we kind of examined that. So the first thing I did and approached it was like, how hard is it to understand the concepts of components, right? How integrated is it from end to end? So one of the beautiful things about React is that it is just the UI layer. It doesn't make any decisions about how we manage data. It doesn't make or even fetch or talk to systems or store systems. But that's also a double-edged sword, right? Because that means we have to manage it. We have to find a solution to actually solve that. So it's like, okay, that's a strike for and against React. The first time I started playing with React, honestly, it's like one of those ideas that you have where it seems so complex in the beginning. I go like props, it's state. Like I understand the theory, but it's can't apply it. And I'm starting to build it. When do I pass it down? And then all of a sudden one day I just woke up and it made sense. I look back and I'm like, how did I not understand that? But I knew that was going to be an important cognitive load issue when I actually started getting my team up and running on this. But then I started looking at other frameworks, and I'm like, wow, like these are even more like declarative syntax and all those things in Angular. Okay, Knockout was like, I don't even know where it enters, and like having to figure all that out. So that comes like, oh, okay, it's simplifying. And then it was like for me so just like right, like there was a nail in the coffin. Said yes, this technology was implementation. The idea that I can build everything very small and shareable, and that's something that's really been revolutionary in the JavaScript space because of our build systems. We're finally to a mature space that I can have thousands of small JavaScript files and not want to kill myself. We actually did this, so I actually worked on Sign.com and Lexis and Toyota for a long time. And my friend architect I work with, he came up with a whole build system that allowed us to do this. It was revolutionary at the time. But that was what always killed us. Like that's where I was a Flex developer and a Flash developer. We had this built-in ActionScript actually had the compiling. So that was a general idea. So all of a sudden now it's like, wait, I can work the same way. I can make everything super small. And now I can have a team of 30, 40, 100 people working in a UI project and kind of start isolating them and not having them step over each other. Now, a lot of other frameworks do that, but I felt React did it in the cleanest, most elegant way. And that's what really kind of like brought me into the fold. It was like, yeah, this thing was really cool. And then once you start working with it, this made a lot of sense. It had the lifecycle, which was familiar with. So it was like, okay, cool, I get this concept. So those are kind of like the path that let me down. And it was tough because I actually looked at these other frameworks and I was like, it's a multi-billion-dollar company going like, I'm going to tell you to not stop using this technology you've been investing in for 8 years because I hate it. And then like, but I actually vouch for why I hate it. And that's what led to actually working with the team and figuring this out. So I hope that kind of rambled on a little bit.
And maybe just one or two. I was wondering what the learning curve you said is to the point where about how long would that take and what is that more or less what other people discuss with experience?
Yeah, so the question you guys didn't hear was the learning curve. What was the time? That's kind of a loaded question. Here's why. There's React, but there's the whole ecosystem, right? And so how familiar are you with the rest? This is the one thing that I spend a lot of time on Reddit. I spend time on Discord, React Clubs. And that seems to be the most common problem. It's not only do you have to actually learn React, but do I learn Redux? Do I need to worry about Webpack? Do I need to worry about Babel? Am I using ES6? What ways do I build? So the fundamental principles of React, and that doesn't even talk about native, because that's that actually another layer on top. But the fundamental how componentization works, I honestly think you can get up and running, like doing one of the demos in like 15 minutes. Conceptually, it took me about a week of actually 2 weeks of really working with it before it started to click. I wouldn't say I was good at it, but it clicked. I've been working with it for about 1.5 years now. I'd say probably the last year I felt comfortable. So it's about, I would say it's probably like a 3 to 6 month before you're really confident in your capabilities. But you learn it relatively quickly. The problem is you can start making decisions that you're going to look back. And this is true of any technology, actually. When you're running you're going to go look back and go, what was I thinking? Documentation's gotten a lot better too. There's a lot more consensus. So 1.5 years ago, there was a lot, like Redux was just, I actually haven't even rolled out yet. So there's still a lot of churn. But that's my main, so I think fundamentally you can learn React pretty quickly, probably 3 to 6 months to really like feel like you're crushing it. But then there's everything around that. Like I have a friend of mine who's a brilliant programmer named Jesse Warden. He's been blowing his hair out for weeks now with Redux sockets. So it's just like there's these things like it's gonna trip you up. But fundamentally, I think you're gonna pick it up really quick, which is probably a lot faster than you pick up Angular. A lot faster than you pick up Ember. In certain areas, other areas would be probably quicker. That's my guess.
Yeah, you mentioned the ecosystem of React. Would you, if you could, in a nutshell, give us a quick, like, if you had to, like, the smallest subset of these are necessary to learn. React, obviously, it's Redux in there, it's React Native in there, like, what, to become a viable, like, developer in React?
Sure. So I guess the question is like, native is probably going to be in there now. Like, I think that devices are and will be continue to be more and more important. So that we're going to have to spend some time on that. In fact, we're actually working on React Desktop now, so you can actually start building native desktop apps using React. So I think that that's an element of it. But do I need Redux? Are you building a very large application? No? I wouldn't spend my time on it yet, right? I would actually go and look at the Flux architecture that's developed by Facebook. It's literally one page, it's a concept. It's an interesting, get your head around that, because that's what Redux is. It's an implementation of Flux architecture. Get that concept conceptually, how they manage data and pass data in the system. That's important. So understanding at least the principles of Flux, understanding the basics of React. Where I think it's tricky is more about build systems and deployment. Do you spend the time mastering Webpack? Are you using another build system? Are you using Brunch? Are you using something else? Is it Gulp? Is it what are you using? And if you're not using any of them, you have to learn one. I prefer Webpack because it's been the most successful in my mind so far. But that's my personal opinion. But, that's the challenge. And I think this is the biggest challenge. Is that every week there's a stupid new build system. There's a stupid new library. Okay, it's Vue 2 today. Great, awesome. But I think those are the key. How do I get my content written and tested? How do I get it deployed? Those are the two biggest challenges that we have. Native adds another mix into that because now, am I deploying to iOS? What is that whole show like? I'm deploying to Android. What is that whole show like? That's just another pipe in that chain. But once you understand how I can actually build an app, and get it functioning, and then actually getting deployed. So it's really, understand your React, look at Flux. If you're doing any kind of testing, and UI testing, look at Jest. That's right there, because Jest is a pretty good testing system. And then, how am I deploying it? Is it native? Is it not? And understanding that.
I would just add that you might want to, outside of your talk, but the decision to write in JSX or not in JSX. That's a big.
Yeah, so that's a good point. Am I using JSX or am I not using JSX? I professionally became a JSX fan. I am a JSX guy. So for those who don't know what JSX is technically it's like a language that it's just it's like CoffeeScript. It's like a proto language, DSL, right?
Yeah.
Yeah, it's a DSL that gets baked down to JavaScript. So it allows you to write XML, HTML-like syntax that represents your components. If you're using the browser, represents DOM elements, divs, things like that, and then it converts it over into what actually React is really doing. All React is really doing is it has a series of create elements, and then it passes over. So you can use all raw JavaScript. You don't have to use JSX. I like it because it's easy to read. Honestly, once you start getting the nested children, raw JavaScript is kind of a nightmare. That's a really good point because that's a build step, right? If I want to use JSX, that means I have to tie into a build system. So where did that fall into? So great point. Thank you for bringing that up. Yeah.
All right, everybody, let's give it up for James. And I try this group needs speakers. I know a lot of you guys are beginners, but beginners have things to say too. There's a ton of people for you to speak to. This group is almost half beginner and no experience. So we need your talks. We need your experience, your beginner's experience, your beginner's perspective, as well as the intermediates and the advanced. So please get involved. Consider speaking, getting up here and speaking in front of everyone, sharing your experience, because we really need that in order to keep this group going and keep it interesting. And you can, there's a link on the meetup group where you can officially submit your talk proposal. All right, and we also need your attendance and your support to help spread the word, and let's make this a big thing. All right, thank you. There's a little bit more fruit left, maybe a little bit more, and a lot of desserts. So let's clean this place off.